All right, continuing on with solving equations. Our first two answers look pretty similar. Our next two are going to look pretty similar as well. So remember, our whole goal is to get the variable by itself. Now notice in C, the variable is on the right side instead of the left. So that means that I want to get everything that's with it on the other side. So the 3 is the only thing that's with it. And then you always want to look at the sign in front of the 3. It is a positive 3. So I want to do the opposite of plus 3, and I want a minus 3 to both sides. Now why? Because remember, you want to cancel it out. 3 minus 3 is 0. So that means that I have x equals negative 11 plus a negative 3, the same sign, so I'm going to add and keep the sign. So x equals negative 14. So whatever is with the x, you just want to move it over. So if you have addition or subtraction, and when I say addition or subtraction, I'm talking about here, addition, subtraction, addition, addition. These are things that are beside the variables. So when you have addition or subtraction right there beside the variables, you want to do the opposite of operation of whatever that number on the other side of that addition or subtraction to get it away from that variable. So what's with the variable in D? An 8. And the 8 is, again, positive, just like the 3 was positive. So I want to move that 8 over by subtracting 8 to both sides. So I want to subtract 8 to both sides, and again, 8 minus 8 cancels out, and I'm just left with the z, and I'm going to have z equals the same sign, so I'm going to add and keep the sign. So I'm going to have a negative 16. Now, E is when it gets a little different. We have different looking equations here. We have variables on both sides of the equal sign. So this is going to get a little bit tougher. It's not really hard, but it's just a little tougher. So notice that I have an x on the right and an x on the left. Remember, your first step is to move all your variables to one side before you can really get the x by itself. So that means that instead of moving numbers away from the variable, I need to move this variable to meet up with the other. So I want to move my variable 2x to meet with the 3x. For the only reason I move my variables to the left is to help us when it comes for our section 2.7, solving inequalities. And if you get yourself in a habit of always moving your variables to the left when you have the opportunity, it's always good to have something that you do always, so you're prepared for that move, because a lot of my students, I see they have problems with knowing what to do next. So like on our first 4 examples, there was nowhere to move the x because it was already one x by itself. There weren't x's on both sides, so I just moved the numbers away. But in this one, when we have letters or variables on both sides, I have the opportunity to move the variable, and I always choose to move mine to the left. It's not necessarily something that you have to do, but I am going to do it. So I want to move my 2x and I want to move it to the left. So I'm going to do the opposite, and remember, it's a positive 2x because there's no sign there, so I'm going to subtract 2x to both sides, just like I was doing my numbers above. So 2x minus 2x is 0. That means it cancels out on this right side, and I moved it to the left to meet up with the other x. So I have 3 minus 2. That's just going to give me a 1x. So I just have an x equals, what's left over here? A positive 4. There's nothing else to do, so that's my answer. You know you're in simplest form, where you know you have your variable solved if the variable's by itself, there's no x's on the other side, and you only have a variable equals a number. Letter F, the next problem, we have 4x minus 4 equals 3x plus 6. Notice that we have variables and numbers on both sides of our equation. That means that there's a lot of things we could do. I always move my variable first, and I always move it to the left. So that means that I'm going to go for that 3x, and I'm moving it to meet up with my 4x, just because I always do it first. So because that's a positive 3x, I'm going to subtract 3x to both sides. It's going to cancel out on the right side. So I'm going to be left with 4 minus 3, that's just 1x, minus 4, bring down my equals, bring down my plus 6. Now I'm not done here because I don't have the x by itself. So I'm going to move whatever's with the x, in this case it's a negative 4, I'm going to move this negative 4 to the other side. So I'm going to add 4 to both sides. And when I add 4 to both sides, it cancels out. On the left side, I'm only left with the x, and 6 plus 4 is 10. So let's recap what we have just done. We started off with variables on both sides. I always move my variable to the left, and I always move it first. So I saw that it was a plus 3x, so I did the opposite, and I minus 3x to both sides. It canceled it out on the right side, and I had 4 minus 3. That gave me 1x. I brought down everything else. I brought down the minus 4, I brought down my equal sign, and I brought down a plus 6, or a positive 6. Then I wanted to get the variable completely by itself, and this minus 4 was with it. So I added 4 to both sides to do the opposite. So 4 minus 4 cancels out, and the x was left by itself, and 6 plus 4 is 10. And that's how I got that answer. All right, we're going to pick up with G on the next video.